Hello once again, you're welcome to my channel. Today we shall be discussing on how to calculate beam moment of inertia. Now let's read through the question. Calculate the beam moment of inertia of cross-section represented in the schematic below. Today we have a channel inverted cross-sectional shape area of a beam with the width of 25 for the first member, with the depth of 220 for the second member, with the width of 25 with the depth of 220, and the same thing with the third member. Now, how do we calculate the y, which is the distance from the centroid of each member? The first one is a halfway equals the centroid, which is 110. The second member, the halfway from x equals 207.5. The third, we have a halfway which is 110. Now, by calculating the area, we multiply the breadth to the depth of each member. That gives us 5500 for the first member. The second member, 5500. The third member gives us 5500. Now, by producing the product of the y to the area, that gives us 60500 for the first member. The second member gives us 14125 for the second member. The third gives us 605000. By producing the summation of the area of all the member of the beam cross section, that gives us 16500. The summation of the AY, that is the product of the area to the centroid calculated, that gives us 2351250. So therefore, the main centroid of the O cross-section member gives us the summation of AY over summation of A. That gives us 2351350 over 16500. So therefore, the main centroid Y, which is bar Y, equals 142.50 millimeter. Don't let us forget the right equation for the moment of inertia of a beam equals I equals summation of Ix, that is the reference from X horizontally, plus the product of area to the difference in the centroid of each member to the mean squared. So therefore, by using the equation, whereas I equals BD cube over 12, and D, which we were told, equals minus Y minus main centroid, that is the centroid of each member minus the main centroid. So therefore, by inputting all the data, we have our moment of inertia to be 1 over 12 into bracket 25 times 220 cube plus into bracket 5500 plus 23.2 square multiply plus the second member, which is 1 over 12 into bracket 25 times 220 cube plus 5500 times 32.5 squared plus 1 over 12 into bracket 25 times 220 cube plus 550 times 65 squared. That gives us the entry. The first one gives us this entry, the third one gives us this entry, and the last one gives us this entry. So therefore, the calculated, by adding all the entries, the calculated moment of inertia of the beam shape give us 10.14 times 10 raised to the power 7 millimeter raised to the power 4 calculated.